Welcome to CSCR JRF Net Physical Science class. Today it is C6 lecture, crystal structure number 2 from condensed matter physics, or we can say solid state physics. The crystal structure, the second lecture, second class, condensed matter physics crystal structure. Question number 1. The 10 questions we have seen in the previous class, and this is another set. Number 11. A unit cell that contains lattice points only at the coordinates is known as a primitive unit cell, secondary unit cell, layered unit cell, derived unit cell. A unit cell that contains lattice point only at the coordinates is known as dash. Primitive unit cell, secondary unit cell, layered unit cell, derived unit cell. The answer is A. Primitive unit cell. If a unit cell chosen contains lattice points only at its coordinates, it is called a primitive or simple unit cell. It contains only one lattice point since each point at the 8 coordinates is shared equally with adjacent unit cells. അപ്പോൾ 8 കോർഡിനേറ്റ്സിൽ മാത്രം ഈ ആറ്റം വരിക. അത്ര യൂണിറ്റ് സെല്ലിനെയാണ് നമ്മൾ ഈ പ്രിമിറ്റീവ് യൂണിറ്റ് സെൽ എന്ന് വിളിക്കുന്നത്. The axial relationship of monoclinic crystal system is given as the axial relationship. You know there are 3 axial lengths ABC. What's the relation connecting? There are 3 axial lengths and also 3 interfacial angles. And here the axial length connection is what? For monoclinic crystal. A equal to B equal to C, B A equal to B not equal to C, C A not equal to B equal to C, D A not equal to B not equal to C. Answer is D. This is monoclinic. So answer is D. And there is a small explanation. The crystal system is a format by which crystal structures are classified. Each crystal system is defined by the relationship between edge lengths AB and C. For monoclinic orthorhombic and triclinic systems, the axial relationship is given by A not equal to B not equal to C. Next question. The axial relationship of the rhombohedral crystal system is given as dash. A equal to B equal to C, A equal to B not equal to C, A not equal to B equal to C, A not equal to B not equal to C. The answer is A equal to B equal to C. The crystal system is a format by which crystal structures are classified. Each crystal system is defined by the relationship between edge lengths A, B and C for cubic and rhombohedral systems. The axial relationship is A equal to B equal to C. Number 14. The interfacial angles of the hexagonal crystal system are given by alpha equal to beta equal to gamma equal to 90 degree. You write as degree. Alpha equal to beta equal to 90 degree, gamma is equal to 120 degree. Alpha equal to beta equal to gamma not equal to 90 degree. Alpha equal to beta equal alpha not equal to beta not equal to gamma not equal to 90 degree. What is the interfacial angle relation for hexagonal crystal system? Answer is B. That is alpha is equal to beta is equal to gamma is equal to 90. Alpha is equal to beta equal to 90 and gamma is 120. That is the answer. Explanation. The crystal system is a system by which crystal structures are classified. Each crystal system is defined by the relationship between edge lengths A, B and C and interaxial angles, interfacial angles, alpha, beta and gamma. For hexagonal system, the interaxial angles or interfacial angles are given by alpha is equal to beta equal to 90 degree, gamma equal to 120 degree. Next question. The interfacial or interaxial or interfacial, you write as interfacial. RF ആണ് രണ്ടാമത്. The interfacial angles of a triclinic system is given by alpha equal to beta equal gamma is 90, alpha equal to beta equal to 90, gamma is 120, alpha equal to beta equal to gamma is 90, alpha not equal to beta, not equal to gamma, not equal to 90. Next question. Answer is D here. And the explanation is, the crystal system is a system by which crystal structures are classified. Each crystal system is defined by the relationship between edge lengths A, B, and C and interaxial angles A, alpha, beta, and gamma for the triclinic system. The interaxial angles are given by alpha not equal to beta, not equal to gamma, not equal to 90. What is the atomic radius of BCC structure? Atomic radius is A by 2, B A by 4. Oh, the D answer is not given. So that you write as here it is BCC. So BCC, the interaxial distance is A root 3 by 4. You correct us, A root 3 by 4. ആ രണ്ട് വാല്യൂ എഴുതുക അവിടെ. A root 2 by 4, A root 2 by 4 and also A root 3 by 4. ആ സിയും ഡിയും എന്ന് എഴുതുക. സിയും ഡിയും രണ്ട് വാല്യൂ ഈ കാണുന്നത് കൊടുക്കുക. ഏതൊക്കെയാണ്? A root 2 by 4 and A root 3 by 4 എന്ന് അവിടെ എഴുതുക. എന്നിട്ട് ആൻസർ നോക്കുമ്പോൾ നമുക്ക് കിട്ടുന്നത് ഡി ആണ്. അതായത് ഇവിടെ പറഞ്ഞിരിക്കുന്നത് BCC ആണ്. BCC ആകുമ്പോൾ ആൻസർ വരുന്നത് അവസാനത്തായിരിക്കും വരുന്നത്. അത് A root 3 by 4 ആയിരിക്കും. അപ്പോൾ അത് വായിക്കാം നമുക്ക്. അതുപോലെ ഒന്ന് ചോയ്സ് നിർമ്മിക്കുക. ആൻസർ ഡി ആണ്. അറ്റോമിക് റേഡിയസ് is defined as half the distance between the centers of two neighboring atoms. The atomic radius of a simple cube and SCP is A by 2 respectively, whereas it is A root 2 by 4 and A root 3 by 4 for FCC and BCC. Here the case is BCC, so the answer is A root 3 by 4. Next question. What is the coordination number of simple cubic structure? What is the coordination number of simple cubic? Answer A6, B8, C10, D12. The answer is A6. The coordination number is 6. You see the explanation. Coordination number is defined as the number of nearest neighboring atoms in crystals. Number of nearest neighboring atoms in crystals. The coordination number for the simple cubic structure is 6, whereas it is 8 and 12 for BCC and FCC respectively. It is important. The coordination number, the number of nearest neighbors in a crystal system. That is all with your C6th class on condensed matter physics. We continue. Thank you very much.